So, Vanakkam, we will continue our lecture on the engineering seismology. So, last class we discussed about the seismic record. Okay. So, how the 3 component record is been converted into velocity and displacement, and then from displacement to velocity, velocity to acceleration by integration and differentiation method. Okay. So, we also seen that this converted data can be directly used for basically to get your so, to get your peak ground acceleration or peak horizontal acceleration and peak velocity, peak displacement. So, we have also seen that these values are basically sensitive to the, so high frequency the acceleration, intermediate frequency is the velocity and displacement. Yeah, a typical record basically. Okay. So, this is the typical record. So, this will be the acceleration or velocity is the component. So, you can see generally the peak occurs on the S wave portion. Okay. So, this is what we peak. So, generally this portion of the data will be looked at by the engineers very well, and they will use this for the design, as we have seen that during the wave propagation theory that. So, the S wave basically is a wave where the particles are vibrating perpendicular to the wave direction. Okay. So, because of that it creates a large amount of the inertial force and instability in the structure, which need to be considered for the design. So, by looking at this, by taking this value is one of the way you can interpret in the time domain, which is the peak values what you are getting. So, the other way, okay, so where you can get also the interpretation of the record from the time domain parameters we are going to see. So, what is those things basically? We are going to see that as the effective acceleration. So, in some cases the damage may be closely related to the peak amplitude, but others it may be required a several repeated cycle of the high amplitude to develop. So, what it means basically, we actually have the record of this is the peak, okay, which is the highest among all. But you can also see very closely in this record, even though this peak is slightly higher than that, there are other component, okay, of the, so the waveform where this one, okay. So, basically, so this one, this one, this one, this one, this one, which is slightly less than the peak, but it occurs several times. Okay. So, not that all the time the earthquake what you are looking at, okay, the peak value will cause. So, sometime in the record you will have a peak will be slightly larger than the other amplitude of the record. In those cases, the several repeated amplitude may cause a damage of the structure. So, that they come up with the idea of defining the effective acceleration. Okay. So, where the several cycles of the high amplitude will cause a damage. So, the Dumark and all in 1982 described the concept of effective acceleration at that acceleration which is most closely related to the structural response to damage potential upon an earthquake. It differs from and it less than the peak free field ground acceleration or peak horizontal acceleration. It is the function of size of the loaded area, the frequency content of the excitation, which in turn depends upon the closeness to the source of the earthquake and to the weight and embedment and damping characteristic and stiffness of the structure and its foundation. So, this is basically a composite mix of the structural parameter and acceleration. So, a many repeated cycle of acceleration can cause a damage. So, the effective acceleration is such kind of many repeated acceleration has been defined as a effective acceleration. Okay. So, the another one is actually the sustained maximum acceleration and velocity. So, the Nutley 1979 used the lower peak acceleration to characterize the strong motion by defining the sustained maximum acceleration for a 3 or 5 cycles of the record. Okay. A fifth highest absolute value acceleration. So, why he has come up actually, if you watch very closely this both the record shown in the figure, you can see here this was actually the acceleration from the N29W Mullenley Ranch record of the 1972 Stone Canyon earthquake magnitude of 4.2. You can see that a one amplitude which is completely twice thrice the other amplitude in the record. So, the similar a longitudinal record from the Koina earthquake where M is 6. You can see that the most of the amplitudes are almost like you can see equal. Okay. So, such kind of scenario comes, the damage caused by this earthquake is actually lower than this earthquake. So, even though the amplitude wise this may be lower, okay. So, even though the magnitude is high, this amplitude may be high, the magnitude is less, but the damage of this will be more. So, when you talk about only the peak acceleration, okay, it looks like that this is bigger earthquake. It is not so, only the number of repetition also important. So, in order to account this kind of variation in the record, so they defined called sustained maximum velocity, okay, was defined, which is similar to the sustained maximum acceleration. So, which is basically for 3 or 5 cycles of the third or fifth highest value of the acceleration times t. Okay. Third or fifth highest cycle. Okay. So, that maximum is defined as a sustained maximum acceleration or sustained maximum velocity. Okay. Similarly, for the velocity plot you can take that. So, although PSHA values for the 1972 Stone Canyon earthquake and 1962 Koina earthquake records are nearly the same, the quick visual inspection indicate that their sustained maximum acceleration 3 or 5 cycle were very different for these two. That is what you can see. So, you will have this one very high sustained acceleration, this will have the very low sustained acceleration. For the structure required a several repeated cycle of strong motion to be develop a damage, the Koina earthquake would be much more damaging than the Stone Canyon motion, even though they had nearly same PSHA. Okay. So, this was the message we get. So, when you have the sustained acceleration more, you will get a expected have the higher damage level than the PHA if the same earthquake. So, the another one is basically a design effective design acceleration. The notation of the effective design acceleration with the different. So, the Benjamin Associates 1988 proposed that the effective design acceleration to be taken a peak acceleration that remains after filtering out above 8 to 9 h. So, you can take a data and filter it through this range of frequency, then you can take that acceleration as a effective. The Kennedy 1980 proposed that effective design acceleration to be 25% greater than the third highest absolute peak acceleration obtained from the filtered time history. So, this will be like our sustained time history and above 25% can be taken as a effective design acceleration. So, basically, so we have seen that the acceleration time history which you get can be used to get a time domain parameters. Okay, this time domain parameters can be picking up directly from the acceleration time history of the plot. We can see that if you have the 3 form of the plot like acceleration, velocity, displacement, you can get peak horizontal acceleration, peak vertical acceleration, peak horizontal velocity, okay, peak horizontal displacement. Okay, these parameters you can pick up. Apart from that, you can also get the effective design acceleration, sustained acceleration. Okay, so those are all the parameters which you can obtain from the direct record and the effective acceleration. So, there are 3 additional parameters which you can get from the direct time history recorded data. Okay. So, this is why this is called as a time domain parameters. For this you no need to do any processing, only you need to convert. If you have the velocity, you can convert that as a displacement and acceleration. If you have the acceleration, you can convert that as a velocity and displacement. Then after converting, you can look at which is the value is the peak, which is the 5 cycle, 3 cycle values, which is repeated several times. Okay, so those are all the observation will help you to identify the effective acceleration, effective design acceleration and sustained acceleration and the peak horizontal, peak vertical and the peak displacement. Okay, so peak horizontal, peak vertical displacement, those are all the parameter you can obtain from this kind of observations. So, this is the time domain parameters. When you look at the graph, okay, so you can also closely observe that there is a time which involves, okay, where this is actually a t, okay, 1 or Tp. This will be the starting point of the s, okay. So, this will be the Ts, okay. Then this acceleration values whatever you see, it repeats for that and it end with some t e or something like that, you can take it ends. So, this time, okay, also can be directly observed, okay. So, this time you can say that if the gap between the two time as a duration, you can also get a duration parameters as a time domain parameters from the your recorded data. So, basically you can get Tp, okay, which you can obtain from this point is the Tp. So, the another one is the Ts. So, the difference between the Ts and Tp will give you the basically this to this to this will give you the this distance, okay. This indicates that how your seismic recording station is away from the earthquake, okay. This will be equal to Ts minus Tp, this, okay, which you convert in the degree to the your distance. This is the indicate, it says here this one. So, each station you can take this distance. So, if you take a several station data, you can get a multiple informations on this. For example, so if you have the data from one station, so they will get, this is basically a station location, okay. So, then you will get a another station record. So, this is the station location. So, you also get a another station record. So, where this is the station location. So, this is a S1, S2 and S3. So, you know how to find out this. This is what your Tp and Ts distance. So, you will get here, this is basically is the function of Ts minus Tp, S wave, P wave difference. Similarly, for this record. So, by doing this you can basically pinpoint your epicenter. This is your epicenter. So, if you have the one more station, you can also get a depth, okay, that will give you the below somewhere it is. So, that will give you the your hypocenter or focus. So, this is how the T time recorded on the data can be used to extract this kind of information, okay. So, as we have seen that the time arrival can be picked up from the record. So, apart from that we can also get the other time for the different way, that is called as a duration parameters, okay, the time domain parameters which shows a duration of the earthquake. So, which we will be discussing now. So, the duration is the another time domain parameter you can get. So, this is the typical record. So, where you can see basically this record was actually you have seen in the last class where there is a, so this portion I have zoomed in, okay. From here you can arrive Tp arrival time and the S wave arrival, where the S wave is starting that point. So, this two will give you to identify the distance between the epicenter to the station. Many combination of that distance can be used to location of the epicenter point and hypocentral point, okay, can be used. So, minimum you need 3 station to identify precisely the earthquake, okay. So, epicenter, 4 station to identify the depth, hypocenter and the epicenter location. So, this data will indicate this many cycles are repeating, how long these cycles are going beyond some prescribed value is actually discussed in the duration, okay. Because as we have seen in the sustained acceleration, the damage not only the only amplitude, it is also how many times it repeats. So, that means how many time it repeats can be reflected in the form of period or duration. So, duration of the ground motion is function of fault parameters, okay, that is a size of rupturing part of the fault, rupture velocity, path of the source and local site. The duration of the strong motion also important parameter playing direct role in the destructiveness of the earthquake. So, if you have the very high PSHA, but peak horizontal acceleration, but you have the less duration, then it may not cause the damage. But you have the low peak horizontal acceleration, but the long duration it will be cause the this one. That is like hitting a one person with one punch strongly and hitting several times, a medium punch or slow punch will result in a different kind of effect. So, that is the same thing applicable here. So, the ground motion can be characterized peak amplitude parameters such as we have seen earlier. Then the other one is basically the energy carried by the signal represented by the duration of the shaking. That duration parameter we are going to see now. So, a complete characterization of the ground motion must include duration of the part of the signal that considered to be strong. Duration of the shaking is a time interval of the acceleration signal which is seismic motion in significant. So, the duration of the any particular earthquake is basically duration of the rupture process at source, duration due to the propagation of the effect, duration due to the site. So, all these things only reflected in your acceleration time history. So, the application of the duration seismic performance characterization includes seismic displacement of the landslide mass. Okay, the slope displacement increases with the duration. So, it has been observed that the longer duration earthquake can cause a more landslide than the shorter duration earthquake. The pore pressure generation per liquefaction and volumetric strain accumulation in unsaturated soil, the both increase with the number of cycle and thereby duration of the shaking. So, generally the liquefaction hazard where the pore pressure has to generate, the number of cycle helps to achieve the pore pressure very fast and very high level. So, those kind of places the duration of the shakings are very important. So, laterally spread displacement resulting from the soil liquefaction, the damage due to the lateral spread or moving of some object from its original position to other position, the number of cycle repeating is very important. Damage of the structural components subjected to cyclic degradation also is controlled by this duration. So, there are many places where the first earthquake will leave only the cracks, but the subsequent earthquakes or subsequent vibrations can cause a damage. There are cases which is reported in this kind of aspect. So, nowadays the most seismic design code recognize the displacement and inter-story drift are important value for design seismic resistance structures. The force obtained these are based on the peak and spectral acceleration. These parameters do not correlate to the damage. Okay, so, these parameters do not correlate with the damage. Okay, so, do not correlate to the damage and not consider cumulative damage or damage due to the hysteric behavior of the several excitation of the during the life of the structures. Okay. So, this consideration has been put effort by the scientists, and then they thought that studies employing damage measures related to the cumulative energy usually reported as a positive correlation between the duration and structural damage. So, the duration is becoming a part of interpreting the earthquake record. The experience from the number of earthquakes have shown that the little damage to the structures occurred because of the short duration, even though the acceleration factorial amplitudes are very large. So, this was the observation they made. The duration differs from the site to site even during the same earthquake. Site specific relations are essential for the seismic design, as this duration is controlled by the path, source and site. Okay, these are all the informations are included in the duration of the earthquake. So, this is the typical record. You can see that the figure shows 2 accelerogram recorded in San Salvador with 7.6 magnitude. So, the other local event MS4, okay, 1986, their respective acid plot and in a solid and dashed line. So, you can see that both reaches the same level of areas intensity. So, this is actually the areas intensity. We will discuss areas intensity in the little later, and you can see that but over a different period of time. So, in 1986 earthquake caused more damage. Okay. So, because the same amount of energy was imparted to the structure in a 1/10 of the time, thus imposing a greater demand for the dissipation. So, like if you have the very broader level of this, which basically structure get enough time to dissipate, here you do not get enough time. So, it basically get a highly damaging very fast. Okay. So, this is the information which is helped, okay, and then interpreted where the durations of the earthquakes are playing significant role in the damage of the structures, which basically a implication of the how many cycle it repeats. You can see how many cycle it repeats. So, this is the duration which you can understand. Okay. So, this is the typical Uttarkasi earthquake. You can see that the P wave amplitude similarly repeated for so much, then S wave amplitude, then again this one is repeated. So, this will kind of a cumulative effect will result in the higher level of damage than a single value peak at short duration. So, that is the message which we have to take it from here. So, this will help you basically to design properly. So, there are different type of duration parameters, how these duration parameters can be estimated. So, what are the different duration parameters can be discussed in the next class. Okay. So, thank you very much for watching this video. We will see in the next class.